Welcome to this tutorial video. Today we'll be looking at a 5-point median smoothing. This is not to be mistaken with a 5-point moving average smoothing technique. 5-point moving average uses the average of 5 numbers, whereas the 5-point median smoothing uses the median of a set of 5 numbers. The graph we can see here on display shows data in blue, which is looking at the number of births in a hospital for each month of a calendar year, compared to a 3-point median smooth. The 3-point median smooth has removed some of the extreme variation or fluctuations. However, there's still considerable variation in this orange graph as displayed. So let's try a 5-point median smooth. Here's our months. So our raw data starts with January with 10 births, February with 12 births, right down to December with 15 births. So first of all, 1, 2, 3, 4, 5. Let's find the median of the first 5 numbers of births. We rank them in order from the lowest being 5 to the highest being 22, and the median is the middle point. So 10 is our first 5-point median piece of data from this 5-point median smooth. We then go down to our next 5 bits of data and rank them in order of lowest to highest, the middle point being the median again, and the next 5, and the next, so forth. So our 5-point median smooth has the following data. Let's see if we can do this on our calculator. Our CAS, here's our data. Let's first of all have a look at the raw data graphed. So we're looking at births, and we're looking at months. Again, if we wish, we can add a line of best fit through a least squared regression, y equals a plus bx. And there's our data, our line of best fit, and our variations and fluctuations with the original data. We'll remove our regression line because it's not of interest to us. Let's now go back to our data and perform a 3-point median, a 3p median, rather a 5-point median, 5p median. Okay, so 1, 2, 3, 4, 5. Our middle point is against time code 3 equals median, which is a pre-programmed function on the TI Inspire. So we're finding the median of values from B1 down to B5, the first 5 bits of data, and that gives me a median value of 10. We'll drag that down. Keep dragging down. Up the top here we have 2 pieces of information missing with a 5-piece median or a 5-point median. That's because you need 2 points above, 2 points below the central location. So if I was to take time code of 2, I can go 1 above, I can't go 2 above. So down the bottom I'm also going to have 2 bits of information missing, because from here I need 1, 2, oops, I only got 1 piece of information below, and this one needs a further 2 where there's none. Again, to graph this properly, we're best to enter in the underscore and the underscore to avoid errors with our graph. Let's now construct a graph. We're going to graph our 5-point median against our months. So there's our data smoothed. I can add in a linear regression for our data in the form of y equals a plus bx, and it gives me the following. It tells me that y, the 5-point median for the number of births, is equal to 13.523 minus 0.369048 times the time code for the month. If I go back and check that, in the data I have here, there's our smoothing. Let's have a look at our 5-point median smooth. And the graph we have, again, is minus 0.369x plus 13.524. Okay. See, there's a generally downhill trend here, a negative trend, hence the negative gradient. So when we write this as a least squared regression, we say the number of births using a 5-point moving median, a 5-point median smoothing rather, the number of births is minus or negative 0.37 times the time code for months plus 13.52. We can, of course, use our menu here, plot properties, add Y. We can put our original birth in just to show you the difference in our data. Okay, our original data here is the blue variation, a lot of fluctuation, and then our new circles here are our 5-point median smooth. The data is a lot more smooth. It doesn't have those huge fluctuations, and here's our linear regression line by which we can make predictions following this particular least squared regression line.